In this video, I'm going to give you an introduction to machine learning inside of Nuke. To start off, I'm going to explain a general concept of what machine learning is before going into how it can be used to improve your workflows in Nuke. You hear the terms artificial intelligence and machine learning quite a bit, so let's take a look at a simple explanation. Artificial intelligence, or AI, refers to a simulation of a human's intelligence in machines. The term AI can be applied to any machine that has characteristics associated with the human mind. Now, this can range from learning to reasoning to perception. AI can train programs for a specific task and allow it to probe and improve on its own. Machine learning is an application or a subset of AI. It's the science of having computers act without rule-based programming and can learn and improve from experience. It finds patterns in data and then makes predictions of what the results should be. There are different methods in machine learning. Let's focus on the two main ones: supervised learning and unsupervised learning. Supervised learning is done by providing a ground truth. With this method, we have a desired outcome that's needed, and we can also add weight to an input that will decide how much influence it will have on the output. We will use these truths to create a model. Our goal will be to have a function that, when given data and knowing what our desired output should be, returns something predictable. With unsupervised learning, we only have input data and no corresponding output or ground truth. We are not telling the model what to learn, but want it to find patterns and draw its own conclusion. You can think of machine learning in a similar way to how our brains learn. The neurons receive input from the external world, and the brain makes sure that that information is shared with all the neurons to be called on when needed. When that information is required, an immense network of neurons work to sort out that information. You're most likely interacting with machine learning every day. You might be translating a language, sending a smart reply without having to type anything. Maybe it's a personal assistant that knows what time you like to go to bed. Your favorite streaming site that recommends what you should be watching next. A navigation app that knows your favorite route to work. You may even have an app on your mobile phone that can change your appearance and age. And you've probably seen a convincing deepfake video recently. All these uses have been trained to create a model which should output a predictable result. Machine learning is currently being used in the visual effects and 3D industry for specific tasks. It's helping create natural face expressions on CG characters. It's used for various steps in motion capture workflows. There are countless papers and research of examples detailing the possibilities. So how will machine learning help you in Nuke? Well, you can speed up your workflow when you have multiple shots that require the same task. It can help you with tedious tasks that are time-consuming, like garbage matting, beauty work, cleanup. With Nuke's machine learning workflow, you can use the copycat node for these tasks. In compositing, we always have a desired result, so we provide Nuke's copycat node with the ground truth. We can then train the node knowing what we want for the output. There is no limit to what effects copycat can be used for. The pre-trained deblur and upscale nodes are great examples of results you might want to produce. Think about how long certain tasks would take and how machine learning in Nuke will save you time and effort. Artists are at the center of the machine learning tools inside of Nuke. The artist contributes to the quality of the result. They also create and share datasets. Artists can create their own effects and are not limited to the effects already inside of Nuke. With the Nuke's copycat node, the possibilities are endless.